What if you could step into a machine and travel to the past, or jump forward thousands of years into the future? Time travel has always fascinated scientists, writers, and dreamers alike. But is it just science fiction? Or is there real science behind it? In this video, we'll explore Einstein's mind-bending theories, how time dilation actually works, and whether wormholes could be the ultimate time machine. This means time doesn't flow the same for everyone. If you're moving close to the speed of light, time slows down for you compared to someone standing still. This is known as time dilation. This means time doesn't flow the same for everyone. If you're moving close to the speed of light, time slows down for you compared to someone standing still. This is known as time dilation. This isn't just theory. It's been tested. Astronauts aboard the International Space Station orbit Earth at incredible speeds. When they return, they're younger by a tiny fraction of a second compared to people on Earth. Another example, precise atomic clocks placed on airplanes run slightly slower than identical clocks left on the ground. Time literally ticks differently depending on motion and gravity. So, in a way, astronauts are time travelers. Not by much, but it proves that time travel to the future is possible. Thanks to Einstein, time doesn't only change with speed. Gravity affects it too. The stronger the gravity, the slower time moves. Near a black hole, for example, time slows dramatically compared to far away in space. This idea inspired movies like Interstellar, where astronauts spend hours near a black hole while decades pass back on Earth. Believe it or not, that concept is scientifically accurate. Based on relativity, traveling into the future is scientifically possible. If you could move near the speed of light, years might pass for the rest of humanity, while only days pass for you. In theory, a spaceship traveling close to light speed could leave Earth, circle the galaxy, and return millions of years later, having aged just a few years. But what about traveling backwards in time? That's where things get tricky. Relativity allows for certain strange solutions, like closed time-like curves, where space and time loop back on themselves. However, going to the past raises paradoxes. What if you prevent your own birth? The grandfather paradox. Could reality split into alternate timelines instead? Scientists debate whether the universe simply prevents paradoxes from happening, or whether alternate realities might exist to resolve them. Einstein's equations also predict something extraordinary: wormholes. Imagine space-time folding like a sheet of paper, with a tunnel connecting two distant points. Enter one side, and you could emerge on the other instantly. Some theories suggest wormholes might even connect different times, not just places. That would make them true time machines. But here's the catch. Wormholes are unstable. They'd collapse instantly unless held open by something exotic, like negative energy or dark matter, things we don't yet fully understand. So, is time travel possible? Traveling to the future? Yes, absolutely. We've proven it with time dilation. Traveling to the past? Maybe, but it brings enormous challenges and paradoxes. With future advances in physics, quantum gravity, new discoveries about dark matter, or breakthroughs in energy, we might one day find practical ways to bend time. Time travel sits at the edge of science and imagination. For now, it remains one of humanity's greatest mysteries. But every step we take in physics brings us closer to answering the question: can we really journey through time? If you enjoyed this dive into Einstein's theories and the science of time travel, don't forget to like, subscribe, and share this video. Who knows? The future may be closer than we think.